Question number 13, we are given these two curves here and asked to find the point of intersection. And whenever you're asked to find the point of intersection between two curves, what you need to do is solve them simultaneously. So we have one equation which is y equals 2e to the minus x, and the other one y equals e to the x minus 1. So to solve these, I'm just going to set these two equal to each other. So let's say e to the x minus 1 is equal to 2e to the power minus x. Right, so when you're solving equations with exponentials where the power is the x is on the power, a common thing to try to do is to take logs. Now in this case, if we have e to the minus x and e to the x, we aren't going to be able to solve this by taking logs. So what I'll try to do here is first rewrite this right hand side as 2 over e to the x. So e to the power minus x is the same as 1 over e to the x. So we can write that as 2 over e to the x. So the left hand side, I'll leave it like this for now. Right, so what we can now do is multiply the e to the x onto the other side. So if I multiply e to the x onto this side here, so e to the x times e to the x will give me e to the power 2x. Minus 1 times e to the x is minus e to the x. And the right hand side, I would just have 2. Right, so at this point, we should probably realize that this is a quadratic. This is something that can be written like a quadratic. So if I have e to the x and e to the 2x term, what I can do here is to make some kind of substitution. So I'm just going to say, let u equal e to the x. So I can write this term here, e to the power 2x is the same thing as u squared, because that would be e to the x times e to the x. Right, so if I say u squared is equal to that, and if you're multiplying these two, you'd add the powers together, which is why we get e to the power 2x. So I can rewrite this as u squared minus u, and the 2 here, I'll bring that to the left hand side so that we can have it equal to 0 and then solve this. Right, so you can either solve this by plugging this into the calculator or by factorizing. So this one factorizes fairly easily, u plus 1 times u minus 2. So this gives me either u is equal to minus 1 or u is equal to 2. Right? Then going back into terms of x, so because our substitution was u is equal to e to the x, we get either e to the x is equal to minus 1 or e to the x is equal to 2. Now when solving this, I'll do this one first. So if you have e to the power x is equal to something, then x is going to be equal to ln of this number here, right? So in this case, we get x equals ln 2. Now this one here, you could try to solve it that way, and plugging it into a calculator, you'll find ln minus 1 gives you an error. And that's because e to the power x can never be equal to minus 1. So here I'm just going to say no real solutions for this part. Right. So the only solution we get for x is equal to ln 2. Now on this question here, we are asked to find the actual coordinates. So we found the x coordinate is ln 2, and it does say find the exact coordinate. We then need to find the value of y. So to find the value of y, we could use one of these two functions here and just plug in the x value. So I could substitute x equals ln 2 and do this on a calculator. But I think the easier thing to do is, rather than substituting x equals ln 2, if you just substitute e to the x is equal to 2 into this one, if e to the x equals 2, y is going to just be equal to 2 minus 1. So when x is equal to ln 2, we get y is equal to 1. So therefore the coordinates of the point of intersection, so the point P, is therefore given by ln 2, 1.